Good morning. So I thought before I went into details of the presentation, I ought to start by introducing what my group actually does as context. We're responsible for the products and technologies to support large cloud service providers around the world. And as you know, as part of Intel, we predominantly sell to OEMs who turn those into servers, networking solutions, and storage for use. But we also make sure that we engage directly with the cloud service providers because it's important for us to understand their requirements. And that allows us the foresight to develop the products and the technologies that Diane just referred to. Now, that really gives us a very unique perspective and something that I'm excited to share today. And I think there are three things that you're going to hear based on the learning that we have and listening to the world's largest cloud service providers. The first is that there is an evolution in the workloads and in the user experience. And as much as we think that cloud is becoming mature, there's still so much more opportunity. The second is, to support that opportunity, there's going to be a huge build-out in the amount of infrastructure and a huge change in the way that infrastructure is deployed. And then the third thing is that it's really important to have a total portfolio of all of those ingredients to be able to put that solution together. Those are the things that we've learned, and that's where we're going to go ahead and start today. So I mentioned that when you think about cloud, there's been a huge build-out, and the growth rates have been tremendous, both in terms of the services, the software development and deployed, and the infrastructure that's deployed as well. But those have been based off of a number of key applications. They've been based off of things such as search. Search obviously is a huge driver. The amount of information on the internet is tremendous. The number of people accessing it is tremendous, and that drives a huge amount of growth. Social networking. Did anybody really think that Facebook or Twitter 10 years ago were going to be as big as they are today? Obviously, Zuckerberg did, but the rest of us probably missed that. But there's been a huge growth in that build-out in connecting people. SaaS has been another key driver of growth, the idea that more and more enterprise applications can be delivered as a service through cloud. So all these things are going to continue to drive the growth rates. But there's also an inflection coming, and I wanted to highlight a couple of those. The first is really around the user interface itself. Voice and gesture are becoming the new user experience interface. And I don't know about you, but it felt to me like my world changed when it went from everything having to be typed in to touch screens and swiping. But I don't know about you, I still don't interact with people by swiping or touching them. It's really not very polite in most countries. But the way that people do interact is they interact through gesture, they interact through voice. And that's just really starting to occur now. And what you can see is that we expect over the next several years a 20x to 22x growth rate in the amount of mobile usage of gesture and of voice recognition. And I'm really excited that it's starting to come, now, but there's still a huge amount of transformation that needs to occur. Another example is in video. Now, I heard that there's about 5 billion YouTube videos that are viewed daily. That's about one for every person on Earth. Did everyone here view their YouTube video today? Okay. Well, it's not just about the viewing of videos. And what you can see up here is that there's expected to be about 16x increase in the amount of mobile videos being viewed. But there's also a tremendous driver in the analytics or the manipulation of those videos. You need them to perform well across a wide range of different devices and different platforms. Companies want to do ad insertion, so you're manipulating the video. And on top of that, it would be really nice to be able to search the video itself for the content versus just searching the tags in the video. So when you think about it, it may seem like a very mature technology, but again, we're just at the beginning of the inflection. And then another example is in predictive analytics. And Diane highlighted that through what we call the Internet of Things, all these devices that are connected, the cars, the smart signs, the video cameras, all this genomic data that's coming together, all of that represents an opportunity for people to deploy solutions to allow them to be better analyzed and predicted. And Ron will talk about this in much more detail as we go through. But you can see in just these three examples alone that we're really just the beginning of the inflection. And I wanted to really drive this point home, and I thought, I can talk about it all day long, but it would be really compelling to have one of the leaders in speech and voice technology come talk about the inflection that they see. So I want to invite Sean Brown, who's the manager of innovation for their mobile solutions at Nuance, to talk a little bit about the changes that you see. Hey, Sean, thanks.
Thank you, Jason.
Oh, yeah, sure. Yeah.
So on behalf of Nuance, thank you, Jason. I'm very excited to be here today. Nuance is really the forefront leader in speech technology and innovation. One second. There we go. And the stats speak for themselves. To date, over 6 billion handsets have been shipped worldwide with Nuance technology. We're seeing 5x growth in the past year alone with regards to the number of mobile speech transactions that we're processing in the cloud. Over 10,000 app developers are leveraging Nuance technology in their applications. We support over 70 languages in over 65 countries worldwide. Many of you have probably used speech before to dial a friend or dictate an email message to a colleague or to search for a restaurant near you. And with the introduction of natural language understanding, we're seeing speech becoming ever more pervasive. Personal assistants are becoming more commonplace in our day-to-day lives, and the cloud has been instrumental in this growth. Something I could do with a personal assistant today is I could pull up my device and say, I'd like to book a table for two tonight at 8 p.m. at a top-rated Greek restaurant near me. And while it's very simple for me to say in natural language, it actually involves a lot of complex natural language processing in the cloud. First, my speech is translated into text. That text string has been passed through our natural language processors. Atomic concepts are extracted from that string. Things like the party size being 2 or the cuisine type being Greek. That's been passed to an intent classifier, which determines that the intent of my request is to make a restaurant reservation. Then that is the search criteria is matched against the backend database of available restaurants. And finally, a list of restaurants are sent back to my mobile device to view. The incredible thing is all of that happens in the blink of an eye. And we're at an inflection point today, a revolutionary shift of our personal assistants that are moving from them being task-centric to user-centric. And what I mean by this is that the personal assistants of tomorrow will truly understand you. With advanced natural language understanding, you'll be able to literally say anything to them, and you'll get the appropriate response back. They'll be able to inform you. Today's personal assistants are reactive. You need to pull out your device, you need to invoke them, and you need to ask for something specific in order to get a response. But the personal assistants of tomorrow will be proactive. They'll anticipate your needs and deliver the information and the content to you when you need it automatically. They'll be aware of your context and of your environment, and they'll be able to adapt the user experience as needed. And they'll be ubiquitous. They'll be available across all of the platforms that you use in your day-to-day life, whether it be your mobile, your tablet, your desktop, in your car, via wearables, and much more. And all of this will happen across a seamless, fluid user experience. But with this, we face some distinct challenges that only the cloud can help us to solve. Nuance has always strived to deliver the best possible user experience to our end users, and we need to continue to push our systems to be even more accurate via leveraging larger acoustic models and language models across a broad range of languages that we continue to support. We need our systems to be lightning fast and responsive, and we need to continue to reduce latencies across the exponential growth that we're seeing in the number of users that access our systems and the number of transactions that they submit to our systems. And with the new features that we're introducing, we need to be relying on systems that can rapidly process data across a broad range of data sources, from device data to social to messaging, web data, and more. And all of this needs to be accessed from any device at any time. Nuance and Intel have a close relationship, and I'm excited to speak very briefly about a few initiatives that we're collaborating on. All Nuance data centers are powered by Intel Xeon processors. Xeon gives us the compute power needed to handle the types of complex speech transactions that we need to process in the cloud. We're also working on methods to leverage the compute power both on the device and in the cloud in order to maximize performance via balanced computing. We're also working on joint optimizations on Intel-based platforms, looking at both hardware and software techniques, like leveraging GMM acceleration or Gaussian mixture models on Intel CPUs. This will yield faster response times, higher accuracy via leveraging larger acoustic models. And working on optimization techniques to better scale natural language processing to deal with highly complex conversational dialogue systems. So Nuance is really setting the bar for the personal assistants of tomorrow, and we're very excited about the results that the Intel collaboration is going to yield.
Great. Thank you, Sean. I'll take this one. Thank you. So it's pretty compelling, and you get a sense for where it's all going. And then the question is, well, what's needed to make it happen? How do you do this? Well, the answer is simple. You just keep throwing more hardware at the problem, right? If you look at what's happening to keep up with the demand, the infrastructure is exploding. And I want to say, just caveat this, it's not literally exploding. Data center people do not need hazard pay, but you get the metaphor that I'm highlighting. And it's not sustainable. It's not sustainable. Every single transition that we've seen from a technology perspective occurs when the fundamental cost of delivering that service reaches an inflection point. And so what customers are asking us for now is not just how do I continue to get Moore's Law, but how do I beat Moore's Law? What can you, Intel, do for me to accelerate that transition? And it boils down to three key elements. And I'm going to dive into each of these in a bit more detail. But the first is what we call workload optimized technologies. And Diane talked about this. There are different types of applications. And for those different applications, how can we find something that speeds up the algorithm, speeds up some of the functions that are within that platform? The second is the resources themselves need to be composable. And so Diane highlighted the idea and the vision of composability, the idea that the application is what will decide what the server actually needs to look like. But you need the infrastructure to be ready for that. And to make that happen, there's going to be a transition in the racks and in the data center infrastructure itself. And again, I'll talk more about that. And then once you've got the right workload optimization and the right systems across compute, network, and storage that are composable, you need to orchestrate that. And you need essentially the software to decide, here's what the application needs, here's what the server needs to look like, and essentially manage all of that. So these are the three fundamental elements. And I'd like to start with the workload optimized technologies. So Diane talked about some of the slides that you see sort of embedded here, so I'm just going to hit and punctuate it with some of the customer examples. When you look at server workloads, there are some that are very compute intensive, some that are very I/O intensive. And the idea initially in infrastructure as a service was simple. Homogeneity, as Diane pointed out, is key. So therefore, all the infrastructure itself should be uniform as much as is possible. But the reality is that you want uniformity of the instruction set, but you need to make sure that for a high-performance computing workload or a web workload, that you're delivering the right type of scale across compute, network, and storage to be optimal. And so if you look at Amazon EC2, when initially it was launched, it was just one or two instances that were sort of general purpose for all. But today there are over 18 instances within EC2 targeting a wide range of different applications. And that really highlights the need for optimization within those server workloads. Diane talked about storage and the idea that you now have this bifurcation of hot data versus cold data. Facebook's a great example. They don't discriminate whether it's the first baby picture that I posted online or a picture of a beer at some party years ago. They have to keep the photo. They don't get a chance to say, well, let's throw away the beer one. And what that results in is what we call this massive tier, this capacity tier of cold storage. About 82% of Facebook's picture traffic is only for 8% of their photos. So that's the hot stuff that needs to have a very, very low latency, but they still have to have that huge capacity tier for the other 92% of those photos. And if you look at networking, there's also a range of different applications. The amount of compute and the amount of bandwidth that's required in a small office type of gateway is tremendously different than the centralized back office routing that's done in the core of the network. And so you can see those things are different depending upon the amount of processing and the amount of packets that need to be pushed. And just as an example, Nokia Siemens Networks has also been shifting the focus of their platforms. They're looking at their base stations and saying, because I need to do a better job of media processing, I actually have to move more compute out to that platform. So we're in this fundamental shift and change where every customer is saying, how do I optimize better for my workloads, for my customer base, for my needs going forward? And because we provide those fundamental building blocks, they're coming to us and asking us for change. Now, one of the things that Diane highlighted was that, we do a pretty good job from the Prius to the Toyota, bear with me on the car analogy for a second, to the sports car, to the SUV. We've got different products that provide a wide range of capacities across the product line. But you know what? Sometimes it's still not enough. Sometimes customers are asking us for the Formula One, or if you're familiar with the show Pimp My Ride, they want something that's a little out of the ordinary. And that's where this comes in. we are developing a series of workload-optimized technologies, and I want to walk you through a few examples. The first is that some customers are asking us for customized silicon. As an example, eBay. You can think about eBay. They've got these tremendous periods of peaks and valleys. Think about the holiday time. There's a huge ramp up that they need in terms of capacity. Then at night, maybe not so many people buying or bidding online. And they have a very dynamic set of data centers that they want to be able to bring up and phase down depending upon the workloads and how many people are accessing their site. So what we did is we collaborated with them to come up with a custom piece of silicon that actually provided a 50% frequency variation from top down to bottom to allow the systems to actually dynamically scale depending upon their workloads and depending upon their business. I've also talked about how at Facebook we've worked with them on customized silicon to balance performance and power depending upon their unique workloads. So we obviously have a pretty good broad portfolio, but sometimes because of the level of optimization, customers want customized silicon. And you can also imagine that having a CEO who came from managing the fabs is going to be a pretty big accelerator for us in terms of the strategy as well. I feel like a kid in a candy store. I get all kinds of new things that we can play with here. So customized silicon is the first element. The second is around accelerators. And this comes down to fixed functions for a particular type of workload. And I'll give you an example. Vantrix, if you're not familiar with them, they are a provider of mobile solutions to a number of the telco operators. And they actually are doing some of the mobile video. And you saw that there's a 16x increase being driven over the next several years in that traffic. Well, Vantrix said, how do I go ahead and accelerate the processing of that mobile video? They worked with a company called Quickfire, which took advantage of some of the features and functions that we've embedded for media and graphics acceleration in their platforms. Another example is F5. F5 actually takes advantage of some of our crypto acceleration that we've built into our platforms to accelerate some of their security functions for some of their appliances. So putting fixed functions in addition to a standard Intel architecture into the industry provides the acceleration for those workloads, but still maintains the homogeneity of the architecture. And then last, and certainly not least, is some people want extreme low power for high density. And just to give an example here, OVH is a hoster in Europe. They were very excited about our Atom S1200 that was codenamed Centerton on the slide that Diane showed you, because it essentially allowed them to double their web server density within their infrastructure. Well, the good news is that if they were excited about that, then reaching into my pocket, they'll really be excited about this. What you see here is the next generation Atom. It's called the C2000 processor. And this has 8 cores in it in this tiny little package. And it's going to bring the power efficiency that we started with the first generation, but it's also going to contain 64 bits, 8 cores, a high degree of I/O integration, including Ethernet. There's also 2 different variations of this. So there's one product called Avaton, that's what this is right here, which is for servers and for storage. But there's also a version of this called Rangeley, which adds the crypto acceleration through what we call the Intel Quick Assist technology. And so we've got some of those functions for network processing, and as a result, this product and this SoC will span microservers, network, and storage. And in fact, people are so excited about the product that we have over 50 design wins right now across those 3 segments. Now, a little bit more about it. Because it's moving to our 22 nanometer, we're able to get a 7x performance increase. We also are driving better power efficiency, up to a 4x increase in the power efficiency of the platform. It's also so important that we're delivering all of this while maintaining the features that people care about in the data center. Diane is absolutely right. People want consistency. They need 64 bits. They want software compatibility. They expect things like ECC, even in the low end. And we're going to make sure we give them all of those features in this product. So we talked about workload optimized technologies. I want to shift over to the composable resources. So it's not just enough to have the best ingredients and the best silicon. As Diane highlighted, what we need to be able to do is allow applications to create their own server. Well, to make that happen, you've got to get to, as she mentioned, these pools of compute, network, and storage that can be allocated to a given workload. There is a series of steps that we are taking and that the industry is taking to drive toward that architecture. The first one that's already well underway is what we call physical aggregation. And those of you who aren't familiar with the diagram here, what we're showing is a rack, which is kind of the standard building block within the data center. And what people were deploying in the rack was every server had its own power supplies, its own sheet metal, its own fans, and there was a lot of redundancy in that rack. And essentially, we've gone through a phase of redesign and working through organizations like Open Compute to get designs out there that essentially rip out a lot of the redundancy, that essentially lower the cost of that infrastructure by sharing power, sharing cooling, and also sharing other assets such as rack management. So that was phase one. Now what we're doing is we're embarking on phase two. And what phase two essentially does is it integrates the fabric and allows you to share I/O. So many companies are designing rack innovation that essentially might allow you to share higher Ethernet connections, or might allow you to share RAID cards or fiber channel cards at the end of the day. But when you think about a server or a rack with many servers densely packed in there, the idea would be is that you want to have some of those higher I/O resources, whether it's storage or networking cards, to be shared by multiple servers. And by integrating a rack fabric into that infrastructure, by adding optical interconnects, and I'll talk a little bit more about this in just a bit, and by allowing the integration of switches, what you allow that rack to do is have a much faster refresh. It allows you not to have to take out the entire I/O subsystem or the entire network, but to really upgrade the subsystems of perhaps CPU and memory as people want to go ahead and refresh. But then the ideal, which is what we're working on in the future, is getting that entire rack to be completely modular, to essentially separating out the CPU layer from the memory layer, from the storage layer, and the I/O layer, and essentially thinking of the rack as different trays of all of those subsystems. And what that, again, allows you to do is now you can upgrade those subsystems as required, which is incredibly important for cost-sensitive cloud service providers. But it also allows you to get to that pooled resourcing where an application you could see could pick from the blue, the purple, the green to go create its own application. So we are working with many different initiatives and many different companies out there, and I've actually been astounded at the level of reception that people have to this evolution of the rack. And I wanted to have somebody share my enthusiasm. So I wanted to invite Mark Roenick, who's the COO from Rackspace and a great customer, to come talk about the needs for rack evolution. Mark?
Thanks. Good morning. Hey, Jason, I need some help pimping my data center.
We'll pimp your ride, yeah.
Can you do that? All right, great. Well, good morning. I just want to talk a little bit about our partnership with Intel, and rather than explain where we're similar, talk about how our business is a little bit different and why our partnership with Intel is so important. So, and I can say this because I've worked at eBay and Microsoft and some other big companies like that. It is actually, in my opinion, fairly easy to tune a data center when you have maybe millions of customers accessing 4 or 5 applications. Scale's hard, but what we have from a service provider perspective is a really unique set of challenges. And again, that's the first and foremost why we really appreciate the partnership with Intel. So in any given data center globally, we might have 10,000 customers, right, working on maybe 100 200,000 applications, right? Some on dedicated hosting, some in a private cloud, some in the public cloud, right? So it's just a different set of challenges, and Intel's been with us every step of the way as we explain those use cases that keep coming to us. The other thing is our customer set is very unique. So we certainly do work for big internet companies, and so we're certainly familiar with those workloads. But some of the new leading edge customers that we do work for, right, they're using the cloud and private cloud in completely new and innovative ways. And then we have our traditional, right, kind of the older enterprise customers that really need that hybrid what we call the hybrid cloud, which is dedicated, private, and public. So very, very different workloads, and that's why we appreciate Intel really working with us on those, because each one is unique. Just a little bit about Rackspace, over 200,000 customers. We have a global footprint. We operate in the U.S., the U.K., Hong Kong, and Sydney, and soon in Latin America. We're typically in Gartner's Magic Quadrant up in the top right-hand corner from a hosting perspective. And from a hybrid cloud perspective, we hope to continue our leadership in that space.
It's hard to get more up and to the right than where you are.
It is, but we face some stiff competition. We're dancing with the elephants now. Let me just spend a minute. At Rackspace, we're open standards are really important to us. Right? We think that it drives faster innovation. Not think, we know, and I'll explain why in a minute. It certainly allows us to get products to market faster, and it also reduces costs. That's not first and foremost. That's not what we're solving for. The most important thing is the fourth thing, which is speed. Right, so speed to market in today's world is a great competitive advantage. So about 2 years ago, we did something that was either bold or brilliant. I don't know. The market will tell us over time. But we open sourced our cloud operating system called OpenStack. Okay, and we're really pleased to see the traction that it's gotten globally. And we think it's going to create one of the largest federated OpenStack clouds as people start to join different clouds together. And then we're also one of the founding members of the Open Compute Project. And so along with Intel, Goldman Sachs, and Facebook, we endeavor to really change the data center business for a long, long time. The most important thing about Open Compute, and I don't want to do a commercial for Open Compute, but I do think it is something that is getting a lot of traction and is extremely important to the innovation right in the space in which we all operate. Move forward. So I already touched on a couple of these things, but the workloads that we deal with at Rackspace, the virtual and the instance and slice density that we can get on the new Xeon chip has been incredible. We've seen about a 60% increase in workload capability, so that's been a huge advantage for us. We've got improved revenue per watt, which is extremely important when you're a smaller player in the industry, when you're dealing with some of the big guys that have large economies of scale, and that chip has been very, very efficient for us. We've already talked a little bit about the partnership and the accelerated time to market, but the other thing that I think is really impressive with what you guys have seen today is the roadmap, right? And that's where we're able to integrate, get voice of the customer, right, to the engineering staff at Intel. And they help us provide solutions and technology and engineering for the new products and services that we need to bring to market. And then I'm pleased to announce today that our deployment will include the new Intel 10G technologies. And so we're launching open compute servers in our what we call our IAD data center, which is East Coast in Northern Virginia. And that deployment is going on real time. So for that, we appreciate the partnership, and thank you.
Great. Thank you, Mark. Appreciate it. It's been great to work with Mark, not just in open compute, but we fundamentally share the same philosophy that they do about open standards, open APIs. That's what really allows people to drive innovation. And so we've also been a very key partner with them in OpenStack as well, something that we really believe strongly in. Okay, so the rack is evolving, and we're really pleased to be working with Mark and the Open Compute Project on the version that's being deployed today. What I want to spend a little bit of time going through is what's the next generation of the rack architecture going to look like in that evolution to those pools of compute, network, and storage within the rack. So I've got a little bit more show and tell here, so I'll try and do this without knocking a very heavy piece of hardware on the floor. So what you see here, bring this down, is the next generation of dual processor platforms. You can see this is a design that we're working on with Open Compute, but there are lots of others that have different variations of it. But the idea being is you're sharing more of the infrastructure and the resources. This actually happens to be, and I would point to it, but hopefully you can see it good enough. If I point, I'm going to have it slide. These are 3 different trays of dual socket Xeon servers. You can see that the density is high, and this is a high performance infrastructure. Now, because you get the 3 into the rack, what it allows you to do back here is put together a mezzanine. Actually, I'll sort of show it to you real quickly, and then I'll talk more about it. On that mezzanine card that you see back here, you've got a switch. So essentially, the switch is taking PCI Express out of each of the boxes, or Ethernet out of the boxes, and then allowing you to consolidate the I/O and share it, which simplifies some of the cabling. Also, you'll see 2 little black chips, or black heat sinks, essentially, on the left-hand side with cables coming out of them, optics cables coming out of them. And so you've got silicon photonics built into this mezzanine. So both switching, silicon photonics, and then some of the other chips are actually shared management. So the idea being is each of these boards can be streamlined because they don't necessarily all have to have their own stuff. They can be boards that essentially use a standard like PCI Express or Ethernet and then can be consolidated through a switch. And this is a look at the silicon photonics cable. Now this is a shorter one because the 100-meter version is a little unwieldy to hang around with. But you get a sense, it's a pretty standard type of clip. Very, very thin in terms of the cable, and it allows you to drive in the first instantiation 4 by 25 gig. Now, by the way, this whole thing, I should actually put a pitch in. There'll be a breakout session for analysts and for press later on about the rack scale architecture. We're going to go into way more detail as well, but just in case people couldn't hang around with it, I wanted to show you. These are the optics cables. Now, in terms of the benefit that you'd get in something like this, you can see that in many cases, people are still today putting a single 2-socket, or maybe at best getting half-width 2 sockets into something like this. And that's where you see in some of our arrows that you get the 50% density, because we're now able to put more motherboards in there because we're sharing and consolidating the I/O. But the other benefits to it include the idea that you don't have to have power in each of those things too. So you'll notice that there's no power supply in this. So you've got 12 volt essentially to the boxes themselves, and that allows you to consolidate the power supply. And what you see is that there's a 6x reduction in the amount of power provisioning, because every power supply, when you do it by itself, has some overhead, essentially has some unused capacity, and you're multiplying that, say, by the 40 or 42 servers within that rack. And now you're essentially consolidating or sharing that. So think in the rack there'd be a shared power supply, still N+1 redundant, say 6+1 modules in it, to go drive a full rack of this stuff. So that's where you see the improvements in density there. So the other thing that I wanted to show you, and this is what really, again, makes things neat, this will look, in some cases, very much the same, but it'll also look different. You'll note that in the back, it's got the same I/O mezzanine, same silicon photonics, same switch type of technology, but the cards aren't the third width dual processor Xeons anymore. Instead, we've got a whole tray full of Aviton cards. And I'll actually pop one of those out and kind of show you a little bit more about it. This happens to have 30 of those cards, but believe it or not, we have people who have more density than that in their designs. But that chip that was in my pocket, that's this right here. And you can see we've got DIMMs, and it basically uses something that looks a lot like a modification of a PCIe connector to allow you to populate these in. And so you can imagine getting to an infrastructure where, as we continue to increase and go from, say, the Aviton generation or the C2000 series to the Broadwell DE that Diane talked about, you just pop out these cards, pop in new ones, and people are getting more performance and still using that same infrastructure. So we're really excited about a number of different things. First of all, we're making the overall rack more efficient. Second, in terms of commonality, common I/O infrastructure that works across this, but at the same time allowing people to optimize. Optimize with SoCs where a lightweight workload might be required, or optimizing with high-performance Xeons where more performance is required. But at the end of the day, we want to make sure customers have choice in providing a rack infrastructure that allows that. We're very excited about. And again, the idea being that the more you provide that consistency and allow things to stay the same in the I/O, the easier it will be to upgrade those subsystems. And this is a data point that I don't know that many of you know, but it is increasingly important for cloud service providers to be on the latest generation of technology. It's very simple math. If you think about the idea that in the current generation, they spend $1 for a transaction, but in the next generation, they could get 50% more transactions for that same dollar. That drives the economics of the cloud service provider. And in fact, we did some early ship programs. And in fact, we're currently doing early ship programs on our current Ivy Bridge technology. Many cloud service providers are already in production deploying it. And one cloud service provider estimated that the 6-month improvement that we gave them in deploying their previous generation, this was the Sandy Bridge generation, saved them something like $200 million. So there's huge economic value at the scale that companies like Mark drive to be on the leading generation and to be able to rapidly upgrade that infrastructure. So that's what the composable resources are all about. So we talk about workload optimization, and now the rack is going to evolve to these pools of compute, network, and storage. But you need some way of attaching the application to make those resources available, and that's what really software-defined infrastructure is about. So I want to illustrate the problem with something that we and others in the industry call the Tetris analogy. So companies like, and Mark knows this in spades, here's the problem statement no matter who you talk to. It happens over and over again when they're talking about infrastructure as a service. They say, okay, I have to build out my infrastructure. I have to start planning a couple of years in advance. I expect that the workloads that we'll see at that time, A will be 30%, B will be 30%, C will be 30%, D will be 10%. And they plan their infrastructure around that. And then when they get there, they find out that the workloads were really 20, 50, 10, 0, right? They're completely different. And now that infrastructure has been set up assuming a certain demand profile. And what's happening to that infrastructure, think of that rack again, and just imagine for a second that it's being sliced up into different chunks. Well, those chunks now need to fit different types of applications. And now you're trying to take applications that maybe weren't designed for that size square, and you're trying to cram it in there. Some of those applications may be too small. What happens? You've got unused capacity. Others are too big. And what happens there? Well, the customer's not satisfied because the application doesn't run well. And so if you think of it like Tetris, all these different customer workloads, and you're trying to land them, and at the end of the day, you don't want to have any unused space, this is a really hard problem to be solved multiple years in advance. The answer comes from two elements. First is the composable resources, those pools of compute, network, and storage that we just talked that we're architecting out. But the second is having what we call an orchestration solution. And you can think of the orchestration solution as it's the scheduler. It's the thing that's essentially playing Tetris for you. And it's looking at an application and saying, here's what it needs in terms of compute, network, and storage. And it dynamically allocates the resources from those pools to make sure that the application runs consistent with what the customer expects, but it also minimizes resources. So it's an optimization function if you think about it. I want lowest cost, I want lowest power to go run and meet the customer requirements. And we're not there today. It's still very much in the manual phase of trying to go figure out the right size way of provisioning that infrastructure to meet the customer's application's needs. And so we're working with companies from all around the world. Certainly we're working on OpenStack as a way of driving that type of solution for orchestration. But of course we're working with VMware, Red Hat, Microsoft, Citrix, basically everyone that's trying to come up with this cloud operating system to be optimized and take advantage of these pools of compute, network, and storage. Right? Now, one of the key elements that plugs into that orchestration solution, whether it's OpenStack or vCloud, is the software-defined network. And we talked about, in the context of software-defined infrastructure, that the network is one of the most challenging pieces to be able to get right. There are three elements that we are working with in terms of our products and the industry to be able to drive software-defined networking. The first is having an open platform. So as Diane talked about earlier, the thing that we as a company have a good playbook and seem to do well is we provide a standard platform, we make it programmable, and we let the industry innovate and build upon that platform. That's what we're building toward from a software-defined networking perspective. And what you see is the switch that we'll be driving for software-defined networking has Intel architecture or Xeon processors as the control plane. So that's where the applications essentially that run the network would run. We have communications chipsets, so that's the Intel Quick Assist. These are things for like packet inspection or crypto acceleration or pattern matching. Sometimes you want to do processing on that and not use the CPU cycles, and that's where we're embedding some of the acceleration technology for the network space. And then we also have both NICs and switch silicon. So we've made some acquisitions over the past couple of years to make sure that not only did we have networking on the server side, but we actually had the switch silicon that would allow people like, for example, Arista to go build high-performance switches off of. So we've finally built out that portfolio of all of the silicon ingredients to allow people to build that open networking platform. But the hardware obviously is not enough. You need to be able to have a set of APIs or a program to be able to go ahead and land on that switch. And that's why we're very fortunate to have Wind River as an in-house embedded operating system to be able to build out that network operating system and allow companies that want to write their own firewall or have their own network management applications to be able to land on this platform. But then we also want to be able to expose those APIs up to the overall orchestration, and that's where OpenStack comes in, and that's also where other standards bodies like OpenFlow or Open Daylight come in. All of these are designed to support open APIs. Those are the ways in which the network will be managed in terms of taking out the control properties of the network from the actual execution of the network. And so it's the open hardware platform, making it programmable by having an operating system, and then working on the standards and enabling open source software controllers that really put this solution together. Okay. So if we look at the idea of workload optimization and add on top of that composable resources and on top of that the shift in software-defined networking infrastructure, we've got the right plan as an industry then to go enable the next generation of those workloads, to make sure that Sean can actually enable folks in a very cost-effective way to interact with their machines through voice. And what that's going to drive is a tremendous hardware and software opportunity from a platform perspective for the industry. So our customers now have the opportunity, if you total it up, at about $40 billion in infrastructure opportunity by 2016 based on the rate that we're seeing. We've seen the rate of public cloud servers grow substantially. We're forecasted publicly that we expect that to have a 25% CAGR through 2016. Distributed storage to really drive that capacity tier we see growing at 50%. And partially because software-defined networking is still in its nascent phases, we're seeing it grow at 175%. But the opportunity is huge. But it requires a couple of things. It requires making sure that we can deliver solutions. It's not going to come by piece parts solving this problem because it's very complex. And that's why we've been working so hard to make sure that we build that complete portfolio. We believe that we are uniquely positioned to deliver the ingredients to allow the industry to innovate based off of open platforms. We've got the ingredients in servers. We have a wide range of CPUs we talked about. We're customizing or optimizing where needed. Chipsets, SoCs, accelerators, and other platform components. The network's being driven in the transition to 10 gigabit Ethernet, but we also have silicon photonics, silicon and switch silicon to offer. On the storage side, we see the move to flash into SSDs accelerating. And again, we have all of those components to allow companies to optimize their infrastructure. Then to take all of those ingredients and make them into solutions, you've got two components. The rack scale architecture that we talked about, which is the hardware aspect of it, but that gets orchestrated and by the software-defined infrastructure, where SDN is a component of that. And we're also very fortunate that in our portfolio, it's not just the hardware ingredients. Having assets like McAfee for security or Wind River, as I pointed out, for the embedded operating system. We have our own distribution of Hadoop. We're really thinking about how do we enable those solutions, those next generation experiences, through a combination of hardware, industry enabling, and software together. So I want to thank you very much for the time today. I'm obviously very excited about where we're going, and I have a few minutes for questions, if Mark will help facilitate that.
Yep. Thank you, Jason. Okay, so we want to make sure we have enough time for some Q&A for those in the room and on the web. Let's see, I think we have a question. And when you do ask your question, please state your name and your organization. They're in the back, please.
Sergius Michel with Gartner. 2 questions. First one, the Broadwell SoC. Is that a single chip, or is that an SoC implementation as 2 dies in one?
It's a single chip.
And then second one, from a silicon photonic perspective, you had done the major announcement in Open Compute, and you, again, touched on it. You mentioned it's 4 times 25. Availability-wise, deployment-wise, when should we look at?
Yeah, unfortunately for the public domain, I can say, sampling soon. There are different sessions in the afternoon. Under NDA, we'll give a little bit more resolution. So I think since you're an analyst, you might go join us in the NDA session, and you'll learn more about the timelines for it.
Okay, thank you.
Here, Crystal, and a couple rows in front of you. Let's grab the microphone so the people on the web can hear you.
Appreciate it. Anil Vasudeva from IMX Research. Looks like excellent roadmap for the next 5 to 7 years.
Thanks.
The question is, what Diane said in the morning, how do you take, if you were to architect the CPUs into 2 areas, one for the performance and one for power, and if you were to virtualize them, that means gang them together to keep on increasing performance, that would be real pooling of the CPU powers, just like you're doing the pooling for that. And a subsequent question also is, you mentioned the memory. Are you treating SSD as storage or as memory?
Sure. So I'll start by answering your first question, at least as best as I can. The idea behind that orchestration solution, so in an environment where you've got low power SoCs, you've got entry Xeons, you've got more powerful Xeons, you've got Mike, which is a many core infrastructure. All of those will exist in a data center environment, and the job of that orchestration solution, and why we're working so hard to enable OpenStack and VMware and others, is to make sure that the intelligence is there to say, this is the right place to go land the workload. So if we can define rack infrastructure that has essentially those different types of assets to it, then it's an optimization problem. Whether virtualized or not, the orchestrator will essentially allow the right workload to land on the right type of CPU, and that will effectively kind of gang together those resources, which is, I think, what you're asking about. The second part to your question, SSDs today are storage. But we definitely see an evolution toward that. And I think what I was hinting to, and I'll just go a little further in that rack architecture, is that we see a tier of NAND evolving that will be more than just storage, that it will have different types of properties, essentially, that will allow you to do more of, say, caching or pooling beyond just storage technology. And again, that's when we get to that fully pooled architecture out in the future.
I think here in the front. I'm sorry, we have one with the microphone, and we'll go next.
Hi there, Pat Moorhead, More Insights and Strategy. Can you give a little bit more color on your accelerators? I know you have PHY, and I know you have media encoding, special instructions. Is that what constitutes accelerators, or is it something more, something less?
Yeah, and so there are certain ones that I think we're very public about today, and then there are ones where I'll just give you the coming soon. There's a lot more on. So the ones that we have established for a while is graphics and media, as an example, and that's not just the graphics engine. It is fixed function, for example, for media applications, crypto acceleration. And by the way, some of these things we do in hardware, but we also have software products too. There's something called the Data Plane Developers Kit, which has absolutely been picked up in huge form by a number of the cloud service providers, because what it does is it allows you to do network functions offload them to this library, which then is optimized just on standard, Intel architecture. So those are some of the things that we're doing today. They can be embedded in chipsets. In some cases, they're embedded in a component of the SoC, and I can give you plenty more details on that. Sean hinted at the fact that we also have new ones that are being developed for voice. And if you think he did a great job, by the way, of articulating how that works. And there's a big component of it that's essentially pattern matching, right? So how do we put an accelerator together for GMM that can do a better job of doing that and, again, drive down that cost? So there's a lot of things that we're already doing today. And you could think, for example, of MMX, which, go way back to the bunny suit days, right? That too was a fixed function type of acceleration. We've been doing it for a while, but now we're seeing a need based off of the cloud service providers. There's one other thing which I will tell you is that there are a number of companies that are coming to us and saying, we have our own thing. Would you do it for us too? And that's where I said, having a CEO who comes from the fabs and likes the idea of this is, a really nice thing to have. It's a great tool for us.
Yes. Just two quick ones. Nova from VRZone from Singapore. Okay, question one is, since now you have Atom at 64-bit level as well, and of course Xeon and Xeon Phi are there as well, with the future Phi being able to run as a CPU itself, and they all share PCI Express lanes. And if you have low latency silicon photonics interconnect between them in a single rack, could you have unified the shared memory space between them, even maybe without NUMA overhead, but something to enable unify the large virtual or single physical memory space where different CPUs could do various types of operations or inside a common memory? That's one. And the second one is, what's your, if you are willing to share it, what's your thought of impact on ARM solutions, since now you have a very high performance SoC, essentially, especially looking what the AMD is trying to do with Cortex-A57?
Both very good questions. On the first one, which, by the way, I couldn't repeat, you're way more articulate, but I'll give you the answer to it. In an environment where you've got Mike and all of these different things, when we get to that rack architecture where you have just CPU and memory, et cetera, the idea is, and I can't tell you what the secret sauce is that would do this. Raj may allude to some of those things in his talk, but I'll let that be for him. The idea being is that once we get to a point where you can access whatever the protocol is for that memory tier in the rack, then yes, you can absolutely do what you're talking about. So it's on the roadmap. It's probably not tomorrow, but we definitely are doing some things to develop to it. Then the second thing is to comment about ARM, and obviously it's not my business to go too detailed, but obviously they're formidable competition. There's a lot of competition out there. My strategy, I think, is what I should articulate, which is pretty simple, and it's just listen to the customer and deliver the best silicon. And my goal is, if that little chip, I'll pull it back out of my pocket if I can fish it out, right? So if I can do this and I can give people 8 cores, and with my process technology, obviously I can get it pretty darn small, and I can deliver leading performance, I can give the best power efficiency, I can give competitive density, I can give competitive cost, and then I can deliver software compatibility, all the feature sets, and that whole consistency in the range. Then one would have to ask, what am I missing? What am I not doing? And that's obviously the question that we always ask ourselves. But I want to make it an easy choice for customers. I want to deliver the value we can. So.
Do we have any on the web? I'm sorry, I just want to make sure we gave our web viewers.
Yeah, so obviously there are a lot of questions about Broadwell, SoC. Pretty much the one that are most popular are about what kind of workloads is going to address. Is it more like a high end of Avoton, Denverton, or a low end of Xeon fitting between or on top? Pretty much what is it going to do for Intel's ability to have
let the record note that Diane did the Broadwell disclosure, not me. No, but to answer the question just in short, and obviously we don't want to talk too much more about that today because I'm really excited about the one that we've been shipping samples on for a while and is coming soon. But I do think that Broadwell, time will still kind of tell. We're still learning, and we're letting customers experiment and give us feedback on it. I'd say for right now, I expect that it will be probably an extension of where Avoton plays. It's kind of another way to kind of work things up rather than it's sort of a replacement, for example, for Xeon.
Okay. Any questions in the room? Crystal? Oh, yes.
Addison Snell with Intersect 360 Research. You showed these modular server chassis behind you. Where are you with your OEM partners with those right now, or will you have other routes to market?
We obviously are working very close with the OEMs. There are a number of different designs, and I think that's the cool thing about it, is don't expect that all of them are going to look like this. There are many, many different ways and approaches to the same problem. And the key thing for us is let's give people the ingredients and allow them to innovate. We are very far down the path. I would say that most OEMs have something that aligns to the concept in general. And I don't want to spoil any more surprises, but I'd say, coming soon, we'll be talking more and we'll give you some indications of the progress and where people are with their designs. But the two things I can say definitively, almost every OEM we've been working with and has something in this domain. And the other thing, too, is almost every cloud service provider, and by the way, enterprises sometimes, too, where we've talked about this concept, they say this is exactly what we're looking for. And by the way, assuming that they have a large capacity or big scale-out tier. I mean, obviously, this is not something for small and medium business or for a lot of enterprises that may be having diverse workloads and may not need that type of scale. But for anybody who does, we've gotten both great end-user as well as OEM interest in it.
Yes, sir.
Johan Douglas, anantech.com. You talked about the application Tetris problem, and you said that we need some new orchestration software. What do you mean on top of by that? Because we already have solutions like VMware vCenter where you can cut and slice a rack up in memory pools and CPU pools and storage pools. So what will you be adding on top of that?
Yeah. So you're absolutely right. Is today, that is the paradigm. It's take the rack and slice it up. The thing that, and sorry, you're on tech, you can handle the techiness. I apologize if I go a little too deep here. But it's really a lot of the telemetry at the platform, a lot of the things you expose. So what you want to know is, what's the CPU utilization? What's the memory bandwidth look like? What are some of the power indicators? A lot of those aspects aren't coming together. Plus, they don't monitor the application. So the intelligence that we really need to build in is, how do I know? How does Mark know without having to call up the customer and go, how's your application running? He should be able to know that customer A's web server in general ranges between this number of transactions and this number of transactions. And if something goes down one way or the other, let's assume it starts to spike up, that it automatically brings on more capacity and the orchestration level is intelligent versus them having to call up and go, Mark, I need more, something happens. Or and again, the customer can provision new capacity in general, but the orchestration solution ought to be able to get to the point where the application says, here's what I need and when I need it, and essentially the way a server is formed by taking how many cores, how much memory, how much I/O, dynamically changes based on the real-time workloads. And we're just not at that level of resolution, that level of insight, that level of guaranteeing the customer SLA at this point. And I think we'll get there. But and by the way, all of the folks, you talk to VMware, you talk to Red Hat, the OpenStack community, they all know and they're all excited about moving in that direction.
Yep. Yeah.
Hi, Charlie Demergent from Semi-Accurate.
Two more, man.
How does Intel define cloud?
Oh boy, the one question. There's no right answer to it, is there? No. So how do we define cloud? Basically, we define cloud as it's a service delivered over the internet, and it generally, from an infrastructure standpoint, contains a pool of resources to go deliver that service. So it's a very kind of simplified, high-level direction, and if you said it's wrong, I probably wouldn't argue with you. There's a lot of different perspectives on it. Both. We consider it both a service and an infrastructure. So a cloud service is one that essentially is multi-tenant and delivered over the internet, but it's backed also by a cloud infrastructure. And I think the two go hand in hand because people will go, oh, wait a second, we've been delivering cloud services, on mainframe since, 1990. Yes, there's different gradations, but we think both go hand in hand. That's our definition.
So we're going to take one more question. In the back.
Sergis Musha with Gartner again. Earlier I asked you about the SoC being one die, and you made comments about talking to the customers and building what they need. That's the current strategy moving forward. And for those people that believe that Intel in the SoC world, obviously, considering you're not a fabless company and there's only so many product flavors you can run through, let me ask this question on their behalf, is that when we're saying listening to the customers, is it really the hyperscale customers that you're focusing on when you're talking about these SOCs, or are we going to see an environment where we have 20 different SOCs running around in all kind of flavors for all kind of applications? What's the scope of SOC when you're talking about Intel going into a full SOC, especially here in the server business?
Yeah, and so a couple things. First, just to reiterate, we have a couple of different proliferations of this type of SOC, both the Aviton and the Rangeley flavor, and you can assume also there are multiple different variations to hit a range of power and performance needs as well. So we're already going down the path and recognizing that customers want innovation in their SOCs. Now, it's certainly, when we say listening to the customers, it's certainly going to be a balance. We will and will continue to drive more and more derivatives, and we are working on the strategies to continue to figure out what's the right number of derivatives to go make happen. But the customers we're listening to are both the OEMs. So the OEMs have their own specific needs for what they want to see on their platform. And if you look at some of their platforms, there's quite a range there as well. But then there are also large cloud service provider customers that are saying the silicon that's in the platform that I buy from, say, Dell, I want to go see these types of functions in it. And obviously we have to make the case to figure out what we can go do. But do not think that this strategy is equivalent to our old kind of Xeon strategy of one product, broad product lines. We recognize that there are going to be different IPs, different derivatives that are going to need to be targeted towards different markets for it. And that's why we've got the SOC methodology, that's why we've got the process technology, and the other things to go make it happen.
Excellent. Thank you, Jason.
Thank
Appreciate
you.
it. Thank you very much. Okay. We're running a little bit ahead of schedule. It's actually a good thing with a crowd this size. We're going to take a break that was scheduled for 15, but we're going to be closer to 30. There is refreshments right outside for members of the press. The press release is also available right outside. We'll see you back here in about closer to 30 minutes, and please stay tuned. We've got a lot of great information coming up. Thanks again.